Hi, everyone. Just wanted to take a minute to talk about some compound inequality word problems. I felt today we had a couple things going on, and I just felt I didn't do enough justice to the word problems. So I want to go through a few more examples so you can see how they're done. Okay, so let's look at this particular problem. As we look at it, we can see that we're saying an animal shelter categorizes donations based on their total yearly donation. So if you donate less than $100 in the course of a year, you're bronze. Silver would be between 100 and 500. Gold 500 and 1,000, and then platinum's greater than 1,000, greater than or equal to 1,000. And Keenan is donating the same amount each month. So he's donating an amount of money, and he's doing it 12 times a year. And he wants to figure out what will put him in the gold category. So we know it has to be less than 1,000, and it has to be more than 500 to end up in the gold category. So all we're going to do to determine how much he would donate each month is we're just going to divide everything by 12. Okay, so if you simplify these fractions out, this ends up being 125 over 3, which is about 40, I already forgot, 41.67. That's less than or equal to the amount of money each month, or 250 over 3, which is 83.33. So each month he would have to donate between 41.67 and 83.33 to end up in the gold category. If he was above the 83-ish, he would end up in platinum. If he was below the 41.67, he would end up in silver. All right, and if he was very far below the 41, he would end up down in bronze, but he had to be significantly less. All right, so let's look at another problem. Okay, Enrique plans a diet for his dog, River. River consumes between 510 and 540 calories per day. If River eats 1.5 servings of dog food each day, how many treats can she have? All right. So, first of all, we need to figure out what we're actually setting up as an inequality. So we know that at the end, we're being constrained by this many calories, right? So we know we have to be between this many calories. We can include them, right? It's okay if River eats 510 calories, 540 calories, that's okay. And we need to figure out how many treats she can have. So that's our goal. So we're going to look for the number of treats, T. I don't know how many treats, but I do know that each time she eats one treat, she is eating 15 calories. So 15 calories times the number of treats will give her the number of calories she gets from treats. River is eating 1.5 servings of dog food, which is going to be, let's see, 320 times 1.5 is 480. So there's 480 calories from the dog food, all right? So the 480 is the number of calories that River is getting from the dog food. And the 15T is the number of calories that River is getting from the number of treats that she eats. And our goal at the end here is to figure out the number of treats. So right now we're dealing with things in terms of calories, and our goal at the end here, once we divide out by calories, is going to be just left with treats. So when we plug that in, it's going to be 15T plus 480. Okay. Subtract the 480. And again, when we do this, we can subtract it from all sides. So 30 is less than or equal to 15T, which is less than or equal to 60. And then we're going to just divide by the 15. Again, everything gets divided by 15. Everything gets divided by 15. I get 2 is less than or equal to t, which is less than or equal to 4. So what this means is River can eat between 2 and 4 treats a day and still maintain this caloric intake. Okay, so if River ate 2 treats, then River would be down here at the 510 amount of calories, and if River eats 4 treats, River would be over here at the 540 calories. So this is the number of treats that River ultimately can eat. All right, last one. This one should look relatively familiar because I did an example. This example is very similar to your homework problem. So let's just look at this one. Matter is in a liquid state when its temperature is between its melting point and its boiling point. This is a great example of how you can make an OR compound inequality word problem. Suppose that some substance has a melting point of negative 39.67 degrees Celsius and a boiling point of 324.44 degrees Celsius. What is the range of temperatures in degrees Fahrenheit for which the substance is not in a liquid state? Okay, so here's what we're saying. We're saying in this region, in between, it's going to be a liquid because at a boiling point, it's going to start turning into a gas. So anything greater than 320.44 is going to be a gas. And anything less than negative 39.67 is going to end up being a solid. All right. So this is actually going to be an OR compound inequality. Now, we're given this information in Celsius, and it's telling us it wants it in Fahrenheit. Okay, so there's a couple ways you could actually do this. Well, one, you could just convert these to Fahrenheit now, or alternatively, what you could do is you could set up the inequality based on what we have. So we know that it has to be, so the degree Celsius would either have to be less than negative 39.67, and I'm going to do strictly less than, because if this is the melting point, this is not necessary. This is where the change in matter will start. So we want to be less than that. So this would be, it's liquid, and at this point it can now start changing into a solid. Or we want it to be greater than 320 and 44. Now, we are saying that Celsius is equal to 5/9 times Fahrenheit minus 32. So I can just replace the Celsius with 5/9 times Fahrenheit minus 32. Okay? And we're saying that is less than negative 39.67. Or, sorry. Don't need the C there. We're going to replace that with Fahrenheit. 5/9 F minus 32. Now, this is definitely one that you're going to use a calculator for, because unless you know off the top of your head what either of these numbers is times 9/5, then it's not really going to help you. Okay, so let's do, we have to solve for F, right? Times 9/5, because again, to remove the fraction, you just multiply by the reciprocal. So negative 39.67 times 9 divided by 5 is negative 71.406. I'm just going to round at the end. So F minus 32. Or, again, multiply by the 9/5. Okay. F minus 32 is greater than 0.44. 576.792. Okay, now we add 32 to both sides. And negative 71.406 plus 32. So we get negative 39.406, or F needs to be greater than 608.792. All right, so this will ultimately be our range for when this will not be a liquid. So it'll either have to be less than negative 39.406 degrees Fahrenheit, or it'll be greater than 608.792 degrees Fahrenheit. All right, so I hope that these help you out. And if you have any questions, please let me know. Have a great day.